Welcome everybody. So we'll solve today the questions which were asked in your quiz, which was given to you, I think, in 4th week of May, based on the various topics of engineering mathematics. So in this question, in this quiz, there were questions from diverse topics. Okay, so let's go one by one. Okay, so yeah, this is the first question based on the Newton-Raphson method. So this is very important method as far as your competitive exams are concerned. And we have extensively studied this in our regular classes. There are 2-3 types of problems that are typically asked from this. Okay, one is this, where you are supposed to get the recurrence relationship. Another is they will give you the recurrence relationship and you are supposed to find the original function. Okay, and then there is third one, where they will give you some f of x instead of this and some initial value, and then they will ask you the value after some iterations, like that. Okay, so nonetheless, let's start. So here you are supposed to find the recurrence relation for this f of x, which is x square minus a. Okay, so typically we use this scheme to find the square root of x, square root of number a. Okay, so x is basically square root of a, and to find it numerically using this Newton-Raphson method, this kind of correlation is used. Okay, so let's do that. It's a straightforward question. So you should know that the formula, the iteration formula for Newton-Raphson method is given by so the Newton-Raphson. So NR, basically we use it as acronym NR. So NR iteration formula, okay, is nothing but xn plus 1. So that is value of your root at n plus 1th iteration is nothing but xn minus f of xn divided by the first derivative of f of x. Okay, so here your f of x is nothing but x square minus a. Okay, so f of xn will be xn square minus a, and the derivative is nothing but 2x, right? So now you have to plug this value here. So what you can write is xn plus 1 is equal to xn minus f of x is xn square divided minus a divided by 2xn. Okay, but in your options it is they are taking the constant out, so we'll do that only. So let's simplify further. So if you multiply, this will be 2xn square minus xn square plus a divided by 2xn. Okay. So in the numerator, xn 1 square term gets cancelled. So basically you have xn square plus a divided by 2xn. Okay. So now, you can rewrite this, okay, in order to match your options, basically. And how can you do that is basically take 1 by 2 outside and then divide by xn to the numerator. Okay, so therefore your xn plus 1 will be half comes out. Xn square by xn is xn plus a by xn. Okay, and now it looks like whatever options you had. So yeah, it looks like the first option itself is correct. Yeah, that is also true by as per your answer. Okay, so this is your answer. Okay, so this is a very standard formula and very standard question. You are supposed to solve this in this fashion. And apart from this, I told you 2 types of questions. And then there are certain characteristics or important points regarding Newton-Raphson method, like quadratic conversion, etc., etc. So all those things you should be aware of. Okay. So now let's move on to the next question. But this Newton-Raphson method is very important from your numerical methods topic. Okay. Every year they ask 1 or 2 questions from this. Okay, so this is your second question, where you're supposed to find the Laplace transform of a complex or complicated looking function. So now, in Laplace transform, I had given one table in the regular classes for certain functions which are regularly asked. So you are supposed to remember those. So amongst those functions, sine hyperbolic, cos hyperbolic is there. So there are standard formulas for Laplace transform of sine hyperbolic, cos hyperbolic, etc. And then the whole bracket is multiplied by e to the power minus t. Okay, so that comes into the picture because of the shifting property of Laplace transform. Okay, so here you are supposed to use two things. One is the standard definition of or the standard results for hyperbolic functions, and then what happens if you multiply by e to the power minus t to the given function. Okay, so now let's solve this. So basically we are talking about sine hyperbolic and cos hyperbolic function. So we know that standard formula is Laplace transform of sine hyperbolic at, where a is a constant, is given by a by s square minus a square. Okay, and similarly for cos is cos hyperbolic. Yeah, so that is s by s square minus a square. Okay, so first thing you should remember this. If you don't, then you can't solve this question. Now in this question they are asking you sine I, so basically 2t everywhere. So basically you have to put a equal to 2 in this case. Okay. And in the sine hyperbolic there is 3 multiplier. Okay, so therefore Laplace transform of 3 sine hyperbolic 2t is nothing but, see, 3 is a constant, so that comes like that only, and sine hyperbolic 2t will be a is 2, so that will be 2 by s square minus 2 square. Okay, so basically 3 into 2 is 6, and this is s square minus 4. And Laplace transform of cos hyperbolic 2t is nothing but s by s square minus 2 square. So just s by s square minus 4. Okay. And in this question, you are supposed to subtract these two terms. Okay, so if you call this as 1 and this as 2, so 1 minus 2 we have to do basically. So Laplace transform of 3 cos, so we are basically subtracting 2 from 1, cos hyperbolic at minus, oh, it is sine, I think. Yeah, sine minus cos. Okay, so this is sine hyperbolic, and it is not 8, it is 2t minus cos hyperbolic 2t. Yeah, so this is what they have given, and from our calculation it should be 6s square by 4 minus s by s square minus 4. So basically it will 6 minus s square minus 4. Okay, so this much is fine. This is just based on the standard results. But now they are multiplying this whole Laplace equation with e to the power minus t. So therefore you are supposed to use this following property of shifting of Laplace transform. So if you are multiplying by exponential power at to a f of t function, its Laplace gets shifted by that much distance to the left. Okay, so capital F is Laplace transform for small f. Okay, so therefore when you write in this question, they are multiplying by e to the power minus t. So basically this small a is nothing but minus 1. Okay, so it is e to the power minus t into f of t. So our f of t is 3 sine hyperbolic 2t minus cos hyperbolic 2t. Okay, so that means this is our f of s basically, and now that f of s will get shifted by minus 1 distance. So basically this will become s minus minus 1. So basically it will f s plus 1. Okay, so wherever you have s in the f of s formula, you are supposed to put s plus 1 there. Okay, so therefore it will become, 1 second, it is taking some time to load the slides. Yeah, so 6s, so we have to replace by s plus 1 everywhere and in the denominator as well, like this. And now we have to further solve this. So this will be 5 minus s, and this will be s square plus 2s plus 1, 2s remains as it is, plus 1 minus 4 becomes minus 3. Okay, so this is your final answer. So let's check if there is option like this. Yeah, 5 minus s. Hmm. 1 second. Did we do any calculation mistake? Because it should come out as 5 minus s by s square plus 2s minus 3, right? Yeah, it should be like that only. Denominator is okay, but in your options it is 5 minus s is not anywhere written. What is your option? Option B is the correct one. Okay, let me just check 1 second. I mean, these are standard results, so yeah, it is correct only. Okay, so it is 6 minus s, and then if you multiply by a to the power 80, it is shifting by s minus a, that is also correct. So here a is minus 1, so that is becomes s plus 1. Okay, so yeah, it should be 5 minus s in the numerator. So this is the correct answer. Yeah, I'm not sure why these options are like this, but yeah, this should be the correct answer. Okay, because they are saying option B, it is. No, it should not be like this. It should be 5 minus s, if I'm not wrong. Okay, let me just check once. Yeah, it is 5 minus s only. One second. Because in all options it is 1 plus 5s, 1 minus 5s, like that. Yeah, so I don't know. Something is wrong with the options. Answer is this only. 5 minus s divided by s square plus 2s minus 3. Okay, so let's move on. Now the next question is about total differential of a function. Okay, so they have given you a z function, which is function of x and y independent variables, and now the total differential is given like this. Okay, and then there are certain unknowns a, b, c. You are supposed to find a plus b plus c. Okay, so this total differential concept is basically, let's say for a function which is z, and it has two input variables x and y. You write the total derivative or total differential, or total derivative also you can call as dz. That will be del z by del x dx plus del z by del y dy. Okay, this happens because it's a function of two input variables. Okay, so now basically you are supposed to evaluate del z by del x and del z by del y and compare with this expression to find the unknowns abc. Okay, so let's do that on the next slide. So here z is nothing but x power 4 minus, okay, so z is given as x power 4 plus 2xy square minus y cube plus xy. Okay, so now what is del z by del x? That means partial derivative with respect to x, assuming y as a constant. That will be 3x cube, 4x cube plus 2y square plus y. Okay, and del z by del y is nothing but 2 into 2 4xy minus 3y square plus x. Okay, and now basically you are supposed to compare this with these brackets. Okay, so I'll just write it there. That is ax cube minus by square plus y. Okay, this is supposed to be equal to ax cube minus by square plus y, and this is supposed to be equal to cxy minus 3y square plus x. Yeah, so now if you compare the coefficients, from here you can write a as 4 and b as minus 2 and c as 4. Okay, and therefore a plus b plus c is nothing but 4 minus 2 plus 4, that is 8 minus 2, that is 6. And your correct answer should be 6. Yeah, that is the correct answer. Okay, so in this question you only needed to know what is the concept of total differential of a function. Okay, if you understand, it was just comparing the coefficients and getting ABC and solving it. Okay, this total derivative concept comes into the picture primarily in functions which are having more than one independent variables as their input arguments. Okay, we have discussed so many things about this in our regular classes, so we should be able to do this one. Okay. Yeah, then let's go to the next question. So here basically you are supposed to find a Laplace transform of this 1 by the square root of pi t function. See, pi is a constant, so let's say you have this f of t, which is 1 by square root of pi t, and you are supposed to find the Laplace transform of it. Okay, so let's do that. So Laplace transform of this f of t, see that 1 by square root of pi comes out of, because it's a constant, so basically you are trying to find the Laplace transform of 1 by square root of t. Okay, so that is nothing but t power minus half. Okay, so Laplace transform of t power minus half. And here also I had given a couple of standard results in regular classes, and for such this thing, t power n. Okay, so Laplace transform of any t power n function is given in two phases. Okay, one is n factorial by s power n plus 1. Okay, but here the condition is n has to be a positive integer. Okay, z plus means positive integer. Okay, because factorials are defined for integer values, but in our case the power n is half, minus half. So for that you have another formula, which is gamma function of n plus 1. It's not square root, it's a gamma function, okay, divided by same s power n plus 1. Okay, and this is valid for any value of n which is greater than minus 1. Okay, and so it satisfies our condition because here the power n is minus half. Okay, so basically we are supposed to use this.
You are currently the only person in this conference.
Okay, so basically we are supposed to use the second formula. So let's do that and get the answer. So therefore, yeah, so therefore Laplace transform of t to the power n, or I'll just write it as minus half, will be equal to gamma function of minus half plus 1 divided by s power minus half plus 1. So that is nothing but gamma function of half divided by s power half. Okay, and it is a standard result that gamma function of half is square root of pi. Okay, so this is the Laplace transform of t to the power minus half, but our final objective is to find the Laplace transform of that total function, right? So that 1 by square root of pi was already there, and then this square root of pi s power half comes into the picture, so this gets cancelled, and final answer should be s power half, or 1 by square root of s. Okay, so what are the options? 1 by square root of s, that is first option itself. Okay, so that's the correct answer, and it is also correct, okay, as per your answer key as well. Okay, so this is also, see, in Laplace transform, no, many things are just standard results and certain properties of Laplace transform. So if you are aware of those, you will be able to solve those questions pretty easily. Okay, so let's move on to the next question. Okay, so we have this function z, which is also again function of x and y. Okay, xy square plus x square y, and y is also function of x. Okay, so in this case, which of the following option holds or holds? Okay, so basically it is, I mean, it should be only true, maybe truths, but okay, there is no s required here. Okay, so what they're asking is, either to find del z by del x or del z by del y. Okay. Now we can do that because we can convert this z function into function of x or function of y, because x and y are also related in this fashion. So let's first tackle dz by dx. So for that you need to write, z as function of x only. Okay, so what I'm trying to tell you is, wherever you have y, replace it by ln x. Okay, so this will become x into ln x whole square plus the second term is x square y, so that will be x square into ln of x. Okay, so now z is only function of x, and then you just do the derivative. Okay, so first you have to use the chain rule. So the first term will remain as it is plus, so this is derivative of this part only, then x will be there, then you will have 2 into ln of x multiplied by 1 by x. Okay, so this is the derivative of only first first term, and then let's do the second term as well. So here also 2x into ln x, that will be first term, plus x square into ln of x differentiation is 1 by x. Okay, so what do we have remaining? Ln of x square is as it is. This x gets cancelled, so you have 2 ln of x, or I just write x, okay, no need to put bracket there, plus 2x ln x, and the last term x gets cancelled, so only have x here. Okay, so now let's look at the options in what form they are. Yeah, so basically you're supposed to take ln of x common here so that it will match your options. This term is there, then you take ln of x common from here, so it will be 2 plus 2x plus x. Okay, so yeah, that is option number A. Okay, so option A is correct option. This is not correct because the minus sign is coming, that's not the correct reason. Okay, and now similarly we have to verify dz by dy. For that we need to write z function as function of y only. Okay, so let's do that. Okay, so now how do you write z as function of y only? What you do, you replace, see, y is ln of x, right? That means x is e power y. So wherever you have x, replace it by e power y. Okay, so therefore z will become x square, right? So ey square into y plus x into y. So ey y square. Okay, xy square plus x square y, right? Yeah. And now you have to solve this further. Okay, and same thing, nothing fancy we are doing here. So basically, now for dz by dy, again chain rule of differentiation you have to use. Let's do the first term. So we are doing it with respect to y, and ey power 2 is nothing but e power 2y. Okay, because powers get multiplied if they are in this fashion. So basically we are doing e to the power 2y into y. So first term will be e to the power 2y, and then you have y e to the power 2y into 2. Okay, and now this term, let's say 2y e power y plus y square e power y. Okay, so now let's look at the options and see how do you figure it out. So they are taking e power y common from all the terms. Okay, so let's do that. So if you take e power y common from all the terms, there will be one e power y here, then 2y e power y will be there, plus 2y plus y square. Okay, now let's see if any option matches with this. Second option does not, because there is no 2y ey term. Yeah, this option matches, no, because it is 2y plus 2y ey e power y. Yeah, so that exactly matches with our option, no? Yeah, y square 2y. Yeah, so therefore this is option D. Okay, so if you look at this, option D and option A are correct answers. Okay? Yeah, that is also correct as per your answer key. Okay, so this is correct, this is not correct because one term is missing here. Okay, So like that. So this is also one of the questions where you are supposed to use certain tricks in order to convert the function, because they are not asking you to find the partial derivatives. Okay, they are asking you to find the total derivative with respect to x and total derivative with respect to y. So in this fashion, you should proceed. Okay. So after that, I think one more question will be there. Let's see. Yeah. Again, this is also very frequently asked question of this directional derivative. Typically, they will give you one scalar function and one direction also will be given. In this question, the direction is along unit vector j, and you are supposed to evaluate this directional derivative at a certain point. Okay. So it's a standard question, and the standard formula or the standard way for solving this is nothing but, let's call this as dd, directional derivative. Okay. So directional derivative of this function f x comma y at origin. So basically origin is nothing but 0 comma 0 in the direction of, what is the direction of unit vector j. Okay, so that is nothing but along the positive y direction. Okay, j cap. Okay, so in the direction of unit vector j cap. So that is nothing but, you can consider this unit vector n cap as just j cap. Okay, is given by gradient of this f of xy evaluated at that point. Okay, so here the point is 0 comma 0 origin, and you have to take the dot product with the unit vector along that direction. Okay, in this question, the unit vector is directly given. In many questions, they just give you one vector, so that then first you have to normalize that vector and convert it into the unit vector form, and then take the dot product. Okay, so now let's first find the gradient. So your f of xy is 3x square minus 3y square. Okay, so your gradient is nothing but del f by del x I cap plus del f by del y j cap. Okay, gradient is always a vector function. So what will be that? 6x and minus 6y. Okay, so therefore your gradient is nothing but 6x I cap minus 6y j cap. Okay, and now this gradient value at 0 comma 0, which is the point asked in the question, origin, is nothing but 0i minus 0. Okay, so it is just 0. So therefore your directional derivative, or dd if you want to call it, because see, if you take dot product of 0 with anything, let's say j cap or anything, it is still 0. So the directional derivative is 0 in this case, because the gradient function or the gradient of that function evaluated at origin is 0. So therefore your final answer is also 0. And that is your option B. Okay, and yeah, that is also true as per your answer key. Okay, so these are some of the questions, and I think this is the last one. Yeah, so only there is one doubt here about that answer of one question, Laplace transform. Let me just see it again, because I feel the answer that we solved is correct, but there is no option like that. So let me just verify once if there is any simple mistake or anything. Otherwise, we'll close the class or video. Okay. So just a second. Let me check the question first, whether I have written anything incorrectly or anything. No, it is the same. 3 sine hyperbolic 2t. All those things. Yeah, it is 5 minus s. Yeah, it is 5 minus s only, no? No, I think the options are not correct here. Okay. Yeah, it should be 5 minus s, because see, other tricks usually are rationalizing the numerator or denominator. Nothing like that works here. Okay, so there is some problem with these options. Nonetheless, it's okay, leave it. But as long as you know how to do it correctly, it should be fine. Okay. So with that, we'll stop and see you next time. Bye.